Hi, and welcome to the Pre-Algebra Tutor. Now, I know everyone watching this video is coming from a background where you know how to add, you know how to subtract, you know how to multiply and divide, you've had some exposure to fractions, you kind of have some idea about how to manipulate fractions and decimals and things like that in your basic math. And then you get into this topic of pre-algebra, and then after that, of course, you're going to go into Algebra 1 and Algebra 2 and all this other math that follows. And the tendency when you start a course titled Pre-Algebra is to maybe get a little frightened because the title of it sounds difficult. I mean, the word algebra, it just kind of has a natural ring to it of something that maybe is difficult. Well, I'm here to tell you that algebra, and of course the pre-algebra that we're going to do here in this course, it's not difficult at all. It really isn't. It's just a bunch of rules that you have to fully understand. And once you know those rules, doing the stuff is not really difficult at all. It's just like learning a language. There's lots of rules with language. How to make a sentence, how to speak, how to make verbs and nouns and all that stuff. And you know all this because you grew up and you learned how to speak by listening to other people. Well, in this course, the pre-algebra course, and all the other courses that follow, we're going to learn in exactly the same way. We're not going to learn with a bunch of boring lectures. We're going to learn by doing problems. So you're going to see a lot of problems. And I'm going to explain the topics, of course, but we're going to have a lot of problems up here that are going to show you how this works by examples. So you're going to see how it's done by basically doing it, by following along, and things like that. Now, what I'm going to encourage you to do for every section of this course is to watch the whole lesson through without pausing the video a whole lot of times. I don't want you to have a note sheet out trying to take notes. I don't want you to try to pause and work the problems in between me working the problems. I want you to watch and absorb, just like you do when you were 2 years old or 1 year old and just learning how to talk. You didn't have any note paper out then. You were just listening to everybody talk. Now, after you think you understand the topic, of course, you can watch the video again, you can pause and work out your problems then, of course, but I don't want you to do that the first way through. So what is this topic of pre-algebra anyway? I want to give you a little bit of motivation. You are about to embark on a really awesome journey because your basic math, your fractions and all that stuff, very, very important, absolutely essential to everything that we're doing in this course and all the other future courses. But really, algebra is when you first are able to get the tools to be able to solve more complicated problems. How did people invent the first airplane, or maybe invent the first spacecraft, or invent anything that could go into the robotics that can travel and go inside of a burning building and retrieve things, and anything like that in the modern world has all really been designed by scientists or engineers or mathematicians work on these things, and they all have to use math. And because of that, algebra is the very first stepping stone to being able to have those tools to do those things. And the reason it's so powerful really is because algebra and pre-algebra, they're all really about solving for things that you don't know. You always have a problem where you're trying to find the answer to some question, and so you set the problem up. You may not know what the answer to that question is in the beginning, but by solving the equation or setting up the equation that you're trying to use to solve the situation that you have, you'll find the answer. It's a really powerful tool. So we're going to start with baby steps. I'm not going to assume you have any idea what algebra is or what pre-algebra is, and we're going to take it one step at a time. Now, before we get into this section is titled Real Numbers, and we're going to talk about what a real number is and all that stuff. It's just basically learning some definitions of numbers. Unfortunately, you have to cover this in the beginning because every pre-algebra book is going to cover real numbers off in the very beginning, so I'm going to put this at the beginning as well. But before I kind of dive into the topic of this section, I want to just go ahead and say, algebra, pre-algebra, has this reputation as being difficult, in my opinion, for two reasons. Students get put off for two reasons. One, it's because algebra or pre-algebra, it's all really the same thing. So if you hear me say the word algebra, I mean, we're learning algebra in this class. It's just the building foundation for what we're going to learn in algebra. The two things that trip students up and make them think this is difficult is the concept of a negative number. You really have never used a negative number before, really learning anything about algebra too much anyway. But negative numbers, and I'm just going to give you a quick little definition. A negative number is not a difficult thing to understand. Basically, if I tell you that you have positive 3 pencils, you have positive 3 pencils, how many pencils do you have? Well, you have 3 pencils. I mean, that's what it is. You have 3 pencils in your hand. We always use those numbers, but they're always positive. We always knew they were positive. We just didn't say the word. So if I have a positive 3 pencils, that's how many pencils I have, 3 of them. Now, if I say that instead of 3 pencils, I have negative 5 pencils, the negative is basically telling me that I don't really have any pencils at all. In fact, I actually owe you 5 pencils. That's what that really means. So when you see negative numbers, I want you to think about it in terms of what it really is. It's not a magical thing that's this mystical number that suddenly has a negative sign in front and it's so difficult. It's just telling you that I don't really have that many objects. I actually owe you that many objects. So, and you think about it because that's exactly what it kind of makes sense. If I have negative of something, it means I don't really actually have it at all. In fact, I owe you that many of whatever it is we're talking about. So if I have negative 2 sticks of gum, I don't actually have any gum. I owe you 2 sticks of gum. That's what that means. So we're going to talk about negative numbers off in this course, you know, a little bit later, actually during the whole entire course. But I want you to calm down a little bit and realize that it's not that difficult. It just means I owe you something. That's basically what a negative number is. The second thing that trips people up in algebra is the concept of a variable. You see X a lot, or A or B. You see that running around the textbooks a lot. And people open a book and they see a bunch of negative numbers and they see a bunch of letters, and it gets scary because you've never dealt with that stuff when you had your basic math. Well, anytime you see a letter in algebra, try not to get upset, try not to get worried about it. What it really is it's telling you that you don't know what the value of that number is. So we may be trying to calculate something, but we don't know the answer yet. So we assign a letter to represent what we're trying to find. Like maybe we're trying to calculate the surface area of this sheet of paper. You know, the surface area, how many square inches or how many square centimeters, you know, would fill up the sheet of paper. If we were to calculate the length and the width, we'd multiply them together and we would get the answer. But maybe we want to write it down, you know, and represent the area as the letter A, because let's say we don't know what the area is. So we might put the letter A, and we might use that letter in an equation somewhere, because we need to know the area of the object to calculate something else. We might represent it with the letter A. And so that letter A just simply means, I don't know if it's 5 square inches of area or if it's, you know, 16 square millimeters of area. I don't know what it is. I just know that I have the area of something. So I'm going to use that variable is what we call it, the variable. So those are the 2 things that trip you up and that trip people up in algebra, and they're not difficult. Negative number just means I owe you something. I don't have that many. I owe you that many. And a variable is just a letter in algebra that we use because we don't know the value of whatever it is we're talking about. But we're going to calculate that in the end. And that's what solving equations is all about, trying to calculate the value for, you know, the unknown. That's what it is. So I wanted to get that out of the way because a lot of people get upset about that when they start to learn algebra and get worried about it. So we're going to cover all this stuff in great detail. I just wanted to give you a little bit of an advanced preview. Now, getting to the topic here, we're going to learn about numbers, and so we're going to talk about real numbers. So let's just get right to it. A real number, these are all definitions that you'll see in your book. A real number. Whatever textbook you happen to be using, you'll always see a definition for a real number. My definitions are not exactly what you're going to see in the book. My definitions are more, you know, layman's terms kind of definitions to kind of get the point across. But these are the definitions that make sense to me. It's any number that can be located on a number line. And we haven't even really talked about what a number line is yet. We're going to get into that very, very quickly. But basically, I'm going to give you one more sentence. I'm going to put it in parentheses here, and I'm going to put, it's every number or everything except imaginary numbers. Okay, so basically there are these things called real numbers. Every number that you've ever used in your whole life has always been a real number. Every fraction, every decimal, here we're going to be talking about negative numbers, every negative number, every positive number, every repeating number, pi, any number you've ever used has always been a real number, because a real number is any number that can be located on a number line. And we're going to draw a lot of number lines in a minute to talk about that. The basic idea of a number line is, you know, you have something like this. This is a number line. It's basically a line, and you have 0 here in the middle, and here you have 1, 2, 3, 4 here. So these are the positive numbers going this way, and this arrow means these numbers go on and on forever, because you know numbers go on and on forever. And then here you have -1, -2, -3, -4, and of course -5, -6, -7, as you go on this way. So these are the numbers you've been dealing with all in your basic math, and of course we have these negative numbers because I have less than 0 pencils or whatever. I owe you some pencils over here. That's what the negatives mean. So any number that you can plot here is a real number. And so when I have here everything except imaginary numbers, basically an imaginary number, if you've been exposed to it before, great, you already know what it is. If you haven't, then don't worry too much about it, because it's not the purpose of this course to teach you what an imaginary number is. But a real number is every number you've ever used, you know, everything except for an imaginary number. So some examples of real numbers. The number 4. I mean, that's the number that you've used all your life. The number 6, the number 0, the number -3, the number 2.3, the number 2.6. I'm just making numbers up here. The number pi, which as you know is 3.14159, and it goes on and on forever. The number -1.66, and this little bar over the digit means that these digits repeat. So this is -1.6666666666, like that, on and on forever, etc. Okay, so any number at all that you've ever used in your life, you know, anything except the imaginary numbers, the so-called imaginary numbers, anything you can plot on this line. So I could find the number 4, put a dot there. I could find the number 6 over here. I could find the number 0. Pi is 3.14, so here's 3 and here's 4, so 3.14 would fall right in between there. -1.666 would be in between -1 and -2, etc. And we're going to do a lot of plotting with the number line here in a second, but I just want to tell you a real number is basically any number that you could plot. Decimal, fraction, because 1/2 is 0.5, you could plot that right there. So that is a real number. All right, now the next one is one that you probably haven't heard of too much until now. It's called an irrational number. Irrational number. Now, what do you think of when you hear the word irrational? Irrational number. What do you think of? When I think somebody's irrational, I think that they're a little bit crazy. They're not really with us. They're really doing their own thing. They're kind of unpredictable. That's what irrational means. Something that doesn't quite behave right. That's what irrational really is. So irrational numbers are numbers that really don't quite behave right. That's exactly what they are. So let's write the definition. They're numbers that cannot be written as a fraction. They cannot be written as a fraction. And let me go and write one thing in parentheses here. We'll change color to make it clear. And these are going to basically be non-repeating infinite decimals. All right, so some examples of an irrational number. It's better to sort of just show you by example what they are. Some examples of irrational numbers. They're very simple. They're things like pi. Because pi is equal to 3.14159, blah, 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 blah. And it goes on and on forever. And these digits that come after pi, if you got a computer and you actually looked at the digits of pi out to 1,000 decimal places or 1,000,000 decimal places, you would find that these digits never repeat. They never follow any pattern. It's not like, you know, it'll say 15459, 15459, 15459. No, pi doesn't behave like that. It's a very special number. If you look at all the digits, they never actually ever repeat, ever. And believe me, people have been trying to calculate pi out to 1 billion decimal places to see if it ever does repeat, and it never does. So we say pi is irrational because it kind of goes on and on like this. There's no pattern to it. It's not repeatable, and you cannot write pi as a fraction. Some of you guys may think that, or may have heard, that you can write pi as a fraction. I think it's 22 over 7. That's not really true. That's an approximation. The number pi cannot be written as a fraction, and that's why it is irrational. Another number that just an example number that you cannot write as a fraction is the square root of 2. If you take the square root of 2, and we're going to talk a lot about these things a little bit later too. If you take the square root of 2, that's going to be something like 1.4142 ... If you don't quite know exactly what square roots are yet, we're going to get to this a little bit later. But this is a number. You can put it in your calculator, and you press the square root button, and you're going to see a bunch of digits that go here. And if you calculate those digits on and on and on forever, you'll see there's no pattern, there's no repetition, and you definitely cannot write this as a fraction. The only way to get this number is by this. So you can see that my list is pretty short. There's lots of other irrational numbers, but they're not things that really we deal with every day. We see pi all the time, and that's why I put it first, because that's the one you actually know about. That's the one irrational number that most people have ever actually seen before. That's why they're called irrational, because you cannot write them as a fraction. They're non-repeating infinite decimals, and that's what we have here. So if we have irrational numbers that are little weird, wacky numbers that don't quite obey what we think is normal, then the next type of number you might guess would be the rational numbers. So let's go and take a look at that. So the rational numbers. All right. Now, what do you think of when someone is rational or something is rational? The word rational means they're well behaved. They obey the rules. They are things that have a nice nature to them, and they're very calm, cool, and collected, and they're rational. So these numbers should be numbers that are quote-unquote well-behaved type of numbers. And so that's exactly what they are. Rational numbers are numbers that can be written as a fraction. All right, so they can be written as a fraction if they're rational. And in fact, almost all numbers can be written as a fraction in one form or another. So most numbers are actually rational. So let's look at a couple of them. What about the number 0.5? Is this number rational? Well, it can be written as 1/2. So it is rational. You can write that as a fraction. The number 0.25, is that rational? Well, you can write that as 1/4. So it can be written as a fraction, so it's rational. What about the whole number 2? Well, you can write this as 2 over 1. So that is a rational number because it can be written as a fraction. What about the number -5? Well, you can write that as -5 divided by 1. 5 over 1. So it is rational. What about something a little bit weird like 0.6666, and then you put a little bar so the 6's go on forever? Well, it looks like that is irrational, but in fact this decimal can be written as 2/3. If you put 2/3 in your calculator, that's what's going to pop out. So that is rational. This is actually rational. What about the fraction 1/3? Well, of course, it's already a fraction, so it's rational. And what about the fraction -7/8? Well, it's already a fraction. It's a negative. Negative has nothing to do with it. If it can be written as a fraction. Negative fraction counts just as much as a positive fraction. So, of course, it's already in fractional form. So you see, pretty much any number that you can possibly think of can be written as a fraction. Even the weird decimals, even if they're infinite decimals, if there's any kind of pattern to it, like this one is a pattern because it's got 6's going on forever. But you have other decimals out there like, 0.154, 154, 154, 154, 154, on and on forever. That has a pattern to it. Anything like that that has a pattern, you will be able to write as a fraction. Now, I may not be able to tell you what that fraction is, but it is going to be able to be written as a fraction. It's only when the numbers are kind of going off squirrely with no pattern at all and there's very few of those that we really deal with every day. That's what we call irrational. Most numbers are actually rational, which is what we have here on the board. Okay? Now the next thing I want to talk about are what we call integers. Now, we are going to be talking about the word integers a lot. I mean, in fact, all of these numbers are important, but we're going to be using the word integer a lot. Don't let it scare you. An integer is positive, negative, or zero number with no decimal. Now, like I said, in your book, you're probably not going to see that definition. This is my definition, but your book will have something similar. So, for instance, you might have the number 0, 1, 2, 3, 4, 5, ... In other words, 6, 7, 8, 9, 10, 11, 12, on and on to infinity. And then, of course, on the negative side, we've got negative 1, negative 2, negative 3, negative 4, negative 5, ... So integers are really all of these numbers that don't have any decimal point. I mean, in other words, 4.5 is not an integer. 1.2 is not an integer. 0.3 is not an integer. Integers have to be these numbers that are these nice whole numbers. It can be negative, it can be positive, it can be zero. Those are called integers. And we'll just use this term a lot in algebra. You'll see it coming up. But that is my definition of what an integer is. I think it's a good one just to show you what they really are. There's nothing more to it than that. It's just basically the numbers, positive or negative, without any decimals. A whole number Now, the next thing here, the next couple things we're going to talk about here, a whole number, you know, it's useful to know these only because they're in your book and because you're going to see them on a test, but really you're not really talking too much about whole numbers. I mean, you'll just see why in a second. A whole number are the positive integers, and you also include 0. So 1, 2, 3, 4, 5, ... So when you say something is a whole number, it means the positive integers, and also you kind of include 0 in there. So it's just a definition. I mean, there's nothing special about whole numbers. It's just a label. Integers are the positive and the negative numbers without any decimals, and you also include 0. Whole numbers are the positive ones if you also include 0. And there's also another one that you will see in your book. Let me switch colors here. And those are the natural numbers. All right, the natural numbers. And those, actually, let me take this off like that. The natural numbers, just to show you by example, those are 1, 2, 3, 4, 5, 6, ... So basically, these are the positive integers, and you don't include 0. That's the only difference between a whole number and a natural number. The reason they're called natural is because when you're a kid and you're counting jelly beans, if you have a physical object here in front of you, like this pencil or this marker. So I have one marker. And then if I have a pile of markers, I'll start counting them, 1, 2, 3, 4, 5. So those were considered natural because those are the numbers that you use to count things. Typically 0, even though it's definitely an important number, you're not counting objects with the number 0, because usually if you're counting something, you have more than 0. So that's why they call them natural. I guess what I'm trying to say is these two things down here, I mean, they're useful to know for your test, but you're really not going to use them too much in algebra. You're not going to be asked too much in the future. You know, hey, go ahead and list the whole numbers here, you know, in this problem. It's just not something you're really going to see, but it's a definition. Integers you will see a lot, and so that's super important. The main thing to take away from these boards here is that the world is divided into the real numbers are the general umbrella of all numbers that you could possibly plot on a number line. And those are divided up into the irrational, which are numbers that you cannot write as a fraction, and then also the rational numbers that you can write as a fraction. And then getting even more specific, the integers are the numbers here, like you see here, with positive or negative numbers without any decimals, and 0. Whole numbers are the positive numbers including 0, and natural numbers are the positive numbers when you don't include 0. I'm going to draw a little picture for you here in a second that's going to hopefully make that a little bit clear. Now, the next topic, or the next